All right. Hi, my name is Jackie Werner. I am the Scholarly Communications and Research Librarian here at PCOM. And today I'll be talking about research data management, the good, the bad, and the ugly. All right. I apologize if anything goes wrong here. It's the first time I've done this from my desk. All right. Let me put this into presentation mode. All right. Let me check the taskbar. And can you all see the PowerPoint over there? All right. Nobody's saying no in the chat, so I'm going to assume it's okay. All right, let me open this up here. All right. So today I'm going to be talking about research data and why it's important to consider it separately from just your research as a whole. So, first question is, why should you care about research data management? And we're going to be dividing this into three sections. The good, as in how we could use research data management to our advantage, how we could use data management to deal with the bad aspects, and how we can avoid the ugly. And I'll explain what each of those mean. All right, let's start with the good. So first off, we can use research data as an asset. Instead of research just being the end goal of publication, the data itself that you produce in the process of doing that publication, that presentation, that data itself can be a goal. So you can get credit for the data that you've produced, not just the publications. You can publish your data itself, and I'll be going over some of the details of that. And alt metrics, for instance, shares on Twitter or talk about your data can be a valuable way to look at your data and see what is being done with it, even before you actually publish that research or after you publish that research. People might are able to work with your data and not just whatever you publish. Next is the bad. So this isn't actually bad, but it's a requirement that looks like it could mean some more work. So a lot of funding bodies are now requiring you to share your data when possible or have a full data management plan. For the NIH, any grant above $500,000 must submit a data sharing plan. That means you have to make your data publicly available or say why that isn't possible. So when I talk about sharing your data and making that publicly available, it's all going to be de-identified data. So you're not going to be sharing any protected health information. You're going to make sure that any data you share cannot be connected back to the people or things that you're looking at. And if that can't be done, then that's a valid reason why you wouldn't be able to share your data. But you do have to consider it and provide those reasons. For the NSF, all grants must include a data management plan. And I'll go over a tool that's used to make a data management plan that makes it easier than it might seem. The next issue is journal requirements. Some journals now require that your materials and protocols be made available. For example, PNAS, a quote is, "To allow others to replicate and build on work published in PNAS, authors must make materials, data, and associated protocols, including code and scripts, available to readers." And the National Research Council recommends that you have basically your materials and protocols be available so that others can replicate your work. And what this means for you is that you're probably going to want to make sure things are neat and well documented. And this will be useful not just to anyone using your data, but to you. All right, let me check in on chat. All right, everything's going well there. All right, let me figure out how to get this to share again. There we go. All right, next, the ugly. So this is the stuff that we want to avoid through data management. And these have all happened. I'm sure you could think of some other people, definitely not you, this has happened to. Our postdoc left, and now no one knows where the data is or what it means. Where did all that protected health information go? Aren't we supposed to dispose of this data? So having a data management plan and not just letting one person kind of wing it, which I'm sure we've all been that person. But having a plan means that your research is not linked to one person. Everybody understands what's going on. And in the future, if you have to return back to your research and your old data, you know exactly how to find it, where it is, what to do with it. All right. So what can you actually do? There's 3 different things I'm going to be focusing on today. First, you want to understand the data life cycle. You want to follow best practices with your research data. And you want to develop a data management plan. All right, before I go into that, are there any questions? All right, not seeing any. All right, first off, the data life cycle. So there's actually many different diagrams that show the data research data life cycle, and they're all slightly different. But this one from the NYU Library's Data Management Planning Guide is a pretty good one that gets the point across. You're going to start off up here by creating data. Next off, you're going to process data. That means that you get that raw data into a usable format, which might be putting something into an Excel spreadsheet, or putting it through REDCap. Then you're going to be analyzing the data, which is pretty self-explanatory. Preserving the data. This may mean publishing it in some way. This may mean just basically knowing where you want it to be backed up. Next is publishing the data. And that includes both say, articles and presentations based on your data, but it can also include the data itself. And that can include the raw data, the processed data, or the analyzed data. And then you can reuse the data. Not only you, but other researchers can build off this data. And research data management covers all of these steps, including create data actually has a step kind of before it, which is prepare for creating data. So that's where the research data management plan would come in. All right, so let's go over some best practices. And these are, this is going to be very limited compared to, you can take basically an entire course on best practices for this. But this is just kind of an introduction. All right, So first off, you want to plan. This is before you collect any data. These are all the kind of things you want to take a look at. All right, first off, you want to develop data backup policies. And you might know for instance, to back up your digital data in multiple places. But this also includes physical data, for instance. Do you have paper lab notebooks or paper surveys? You're going to want those to be backed up in case of emergency. It could be something like a fire in your lab, but it could also be something just, we put these paper surveys down, somebody accidentally took a notebook home, and now we don't know where this data is. So everything you want to be backed up. Next step is assign responsibilities. You want to have a person or multiple people in charge of collection and management of the data. And if this position is going to change in the middle of the project, which happens a lot with labs, you have to decide how to pass on responsibilities. And this is definitely something you want to plan in advance instead of discovering, oh, my lab manager is leaving in one day and I don't know how the next person is going to pick it up. Next thing you want to do is determine potential data repositories or journals. The journals you're looking at, the reason we want to look at those, see if they require data publication or allow it at all, and what are their guidelines for this. So it's always a good idea to look up journals in advance in any case, but also take a look at different data repositories. And the Research Data Management Guide that I'll go over at the end will show you some examples of that. Last thing you want to do is determine the budget for data. So data costs can actually be part of the grant, especially for something like the NIH, which is going to require data sharing. This can include putting works in a paid repository or salaries for people who are coming up with the data management plan or doing any of the steps in this. So although it may be more work, you could also get more budget for doing this. All right, the next step we're looking at is collecting data. So you want to define and list the types of data and file formats before you start. So instead of just going and kind of making up the names as you go along, before you start, make a list of every type of data that you're going to collect and what formats it'll be in. So once you do that, you want to choose naming conventions. And the names of your files should always have the same info in the same order. And make sure never to use the same name in different folders. For example, just the file data, the Excel file data. That is not going to be useful if it gets the folder hierarchy gets out of whack. So you would name it something like rat data or whatever is specific to your project. You want to use underscores and camel case instead of spaces because sometimes operating systems decide not to like spaces in file names. And you also want to be extensible. So instead of naming something X1 for experiment 1, name it X001. So that means you could have 100 files instead of just one, and then it will show up in order. And when you collect data, you always want to preserve the raw data before you start analyzing it or making it more readable. Just keep it as a separate file, and you can use save as to create a new file and then name it something that shows that it is not the raw data. And I have an example here. So here is an example name for a image file from a rat experiment. Starts off with the series name of the experiment, Ather rat. Next is the experiment number, 01212. Norm means that the rat has a normal heart. The treatment provided is Lipitor. And the slice number is 056. And then .tiff for an image file. So these are obviously going to depend on what experiments you're doing, but basically know each step of the experiment that's going to be changed, and then you want to show that in the file extension. And try not to keep it too long though, because once you get really long file names, you could get into issues. So just try to keep it comprehensible, but no longer than it needs to be. All right. Are there any questions right now? Let me pop over here. All right, looks like we're doing good. All right, next step is describing the data. And one very important thing to have is a README file. So these files are going to be text files, and they are general files for the whole project, describing the organization of the data, who were the responsible parties for each part of the data, and what instruments you're using. And then for each type of data file, so for instance, back here, we have all the images. You want to have specific READMEs. These will define the parameters, the contents, the data and time formats, the measurements, etc. So in this example, you would explain what each part of the file extension means. You would describe basically what's going on and how these images are taken. I believe this example was slices of rat brain image. All right, and you want to have a meaningful directory hierarchy. Don't put everything in one folder. Just have multiple folders. So depending on your project, you might want a folder for each experiment, folder for each rat. Basically, just keep it so that the folders are not too large, but they have just what they need in there, so that you can easily tell where something is going to be. Next, you want a data dictionary, and that's just going to explain all the terms used in the file and folders. So if you have a folder named control, then data dictionary is going to say what's in that folder, etc. All right, next step is processing and analyzing the data. First of all, you want to double check your data entry. If you're using something like REDCap, it's really easy to set it up so that you can actually you can have it marked. This entry has been checked once. Somebody else has to go through and check it, and then they can mark it complete. You also want to use consistent missing value coding. This is something really easy to overlook, but basically pick a single number that you're going to use for a missing value. Something like 999 is usually useful for that. And you also want to document, again, everything you're doing. And here you want to include all the steps that you're taking and the complete software information so that people can replicate it. And this could be, we use SAS to so on and so forth. All right. right, next is publishing and sharing your data. So once again, document everything that you do. You also want to make sure to save data in stable formats. What this means is you want to avoid proprietary file formats like doc for Word files. Instead, look for formats that have lossless data compression and are supported by multiple software platforms. So you want to use .csv for I cannot think of the word, Excel, and text files for anything with text. And on the research data management LibGuide, which I'll be going over at the end, there's a link showing recommended file formats. And you also want to include documentation with enough to make the data reusable. So for instance, the documentation might have the title of the data, the creator, a persistent identifier, like there are basically DOIs for data, you could use that. Funders, the dates it was created, what file format, etc. All right, and the last step of this is preserving. So a recommendation is to keep 3 copies of your data. Have the original, have one on-site copy, and have one off-site or remote copy. And different storage options have different pros and cons. You have personal computers and laptops is probably going to be one of the copies, but data can easily be lost on that. Network storage, PCOM has a lot of network storage, so that is always want to keep a copy there. You could also have external and removable storage, like an external hard drive or a USB file, and those, of course, could be lost or corrupted. And there's also remote storage. So for that, if you're looking at different options for where to keep your data, I'd recommend talking to IT, and they can help you out. All right, next step is backup regularly. And again, our storage at PCOM is going to do that for you, which is very nice. And make sure that any hard to replicate data is backed up daily. For instance, going back to the rat experiments, if you're doing an autopsy on the rat and then taking pictures of the brain, you're not going to be able to replicate that data by bringing the rat back to life. So just make sure that anything you can't redo, back up more often. All right, you want to store the final data using stable file formats mentioned in the last slide. And then we want to determine the duration of storage. So I believe PCOM's guidelines say you wanted to store for 5 years, and if they're going to be if you're going to publish it somewhere, it can be longer than that. And also consider data security. Your security policies should classify the data by the sensitivity level. If your data includes protected health information, you want that in your IRB, you should be talking about how you keep that data secure. And also, researchers should know who's accessing what data and when. All right, before I go into data management plans, do we have any questions? All right. Excuse me. All right. So, what exactly is a data management plan? It's exactly what it sounds like. It is just basically planning what your data will be and what you're going to do with it before you start actually creating that data. And a DMP, data management plan, usually includes these components: data collection, data description, storage, protection or privacy needs, sharing and access, and preservation. And I'm going to now show you a website called DMP Tool, which is a really nice way of just creating a data management plan without kind of having to guess at what you should include. So, all right, let me attempt to show this. All right, I think this is working properly. So this is a look at our data management guide on our research and publishing libguide. Again, the URL is shared in the chat. It's libguides.pcom.edu/research/data management. And here we have some links to a lot of different best practices and requirements. And down here we have help with making a data management plan. So let me click DMP Tool here. And let me go back. All right, so what DMP Tool does is it gives you a guideline for creating a data management plan for whatever project you're using. And it also lets you easily look at requirements and recommendations for each part of the plan. So here I have a test plan, which I will go into here. All right. So this is based on a National Science Foundation grant. And when you create a plan, you could just put your title, grant numbers, abstract, PI, etc. All right, so I'm actually going to go and create a plan first and show you what this looks like when you're starting. Oh, first of all, when you sign up for DMP Tool, you don't have to be part of a specific university or anything. I'd recommend using your PCOM email, but you could just say that you are not. Let me log out. I'll just show you. So get started. All right, and then your sign-in options, you're going to want option 2. Your institution is not affiliated with DMP Tool. And then you would click create an account and just do all this. All right, let me log back in here with sign in. All right, then you could click create plan here. So what research project are you planning? Just to make test here and say this is a test project. Your primary research organization is a non-partner institution. And then primary funding organization. So you really want to look at your funders beforehand, because a lot of these organizations will actually have templates already in here. So that will tell you exactly what you need to do, exactly the information that they require from you. So I'm just going to click a generic NIH template and create a plan. All right, so here we have title, funder, all the stuff I showed you. Then a plan overview. So this will tell you what the funder requires. And you don't actually have to be linked to a funder. It just is a lot easier to select one because it gives you some guidance. So this one actually does not give that much guidance. The instructions are just, you need a description of how final research data will be shared or explain why it isn't possible. So I'm going to go back to my dashboard here and go back to this. So this one, I chose the National Science Foundation as my funder. And if you go to Plan Overview, this has a really nice template explaining exactly what parts of what you have to share here. So instead of just a single text box, it says exactly what type of data and materials produced, standards, formats, and metadata, roles and responsibility, and so on. And then when you go to write the plan, each of these sections are separate here. So let's start with data and materials produced. And here you have just a rich text box here. And I just realized I've spelled participants wrong. There we go. All right. So this tells, so here I talk about exactly what type of data we'll have. The blood draw is going to be data that's entered into REDCap. Quantitative instruments, paper forms that are entered into REDCap, and it talks about exactly what questionnaires I'm using and how many times this will be collected. Participant information. This paper files in the Excel spreadsheet will keep track of the participants themselves, and analyze data, what you'll be doing to analyze it. So here you want to note you're talking about exactly how you're collecting the data, what different measures you're using, and this even includes like how you're going to analyze the data. So know what software you're going to use. And over here on guidance, there's some really helpful links from the NSF just talking about exactly what you need to have in here. And if you click DMP Tool, that's DMP Tool's advice on what you're going to talk about in each section. There's also a comments section here. And if you're collaborating, you could just add comments and you can all work on the same form. All right, I'm going to save this so it doesn't have that typo. And here you're going to do the same type of thing for each of these questions. And in the advice given back here on the data management plan section, these have actual examples of what data management plans will look like. So I highly recommend looking at existing data management plans to see exactly what you want to be making. And the thing about these plans is that they seem like a lot of work, but doing the work at the beginning of your project and codifying what you're going to do is going to make the rest of it so much easier. You don't have to worry about who's going to be doing data capture and who's going to be doing the storage and backup. You don't have to worry about scrambling and looking for a repository for your data afterwards. And it's just really nice to know this at the beginning, because everything you do at the beginning means less work throughout the project. And you're not going to be scrambling to keep everything where you want it to be. All right, and then the DMP tool also lets you share it. You could set it so anyone at your organization can view, or that anyone in the public can view. This is not letting me because I marked it as a test plan. And you can invite collaborators, make them a co-owner, editor, or read only. And then you could actually download it, which is recommended, just having the PDF so that you have it handy. All right, so that is the very basics of data management. And it's a pretty complicated subject, especially if you haven't gone into it before. So it's going to take some work to get used to considering all this, but it is really worth it. It helps make everyone's research more replicable, and it makes it much easier to build on the research of other people. And that if people are building off your research, you can get credit for that, and not just for published papers, but for the actual data that you've presented. And all of this just makes science a lot more transparent. All right, do we have any more questions? All right, doesn't look like it. So this will be up on YouTube soon. And again, the slides are available on my digital commons site, and I will post that link and the link to the data management guide when we put this up on YouTube. All right, thank you all, and have a good day. Stay safe.